Hello, everyone. Welcome to our final walkthrough of the AspireCTF. We have been having these walkthroughs on Wednesdays, and we've gone through 10 previous walkthroughs. All of these are on our YouTube channel. So that's the ICRAL YouTube channel. So if you missed any or you're trying to do any of the challenges and you want some reference, you can go and view them there. The CTF platform is still active and open for anyone willing to try out their skills. It's at cyphercode.dev. So you can log in, register, and participate in the challenges. After this walkthrough, we will be coming up with a new plan. So we may do some new CTFs in future and also some other programs. So be on the lookout on our channels, that's social media channels, for any updates that we post out. So for today's session, we will tackle mobile security. And the person who is going to take us through the walkthrough is the creator of the challenges. His name is Martin. He is a researcher at ICRAL, and one of his specialties is mobile security. So he's going to take us through all the challenges, then we are going to wrap up at the end. So any questions can be asked either on our YouTube channel where this session is being recorded, and so we can answer for your questions either now or in future. So ask them and we will try to have the responses for you. So I would like to introduce Martin, who can then start us through our walkthrough. Welcome, Martin.
Thank you, Christopher. My name is Martin Getonga. I'm a security researcher at ICRAL Innovation Hub. Currently, I'm focusing on mobile security. Christopher.
Go ahead, Martin. Can hear you.
My name is Martin Getonga. I'm a security researcher at ICRAL Innovation Hub. Currently, I'm focusing on mobile security. My background was I graduated last year from University of Nairobi. I was doing a bachelor's of mathematics and economics. But during my undergraduate years, I was doing some programming. Then I started researching about cybersecurity. And from there, I got an interest in reverse engineering, mobile security research. And then I started doing some CTFs. Then from this year, that's when I started doing mobile security professionally. Yeah. Currently, I aspire to be a vulnerability researcher. Currently, I'm focusing on kernel internals, system internals, and doing some web security and mobile security, browser security. Yeah. I think that's all.
All right, I think you can start the walkthroughs immediately, so you can go ahead and begin.
Okay, let me share my screen. This first.
Still can't see your screen.
Let me change one thing.
Okay. So while Martin shares his screen, we'll also do a walkthrough of the She Hacks CTF we did. So I think that will be in coordination with their campus outreach program. So again, we will also communicate when that will happen, hopefully over the coming weeks. So again, any challenges, any questions? We also have a WhatsApp group that we usually use for the Aspire participants. So if you are interested in that group, you can request us and we will add you to the group where you can also interact with other mentees and also learn from them. Upcoming activities will include outreach programs. So we'll also be looking to visit various institutions and also interact with you on a more personal level. So look out for that too. We have a Discord channel too, where we also have a platform where we can interact, where we share updates, and we will share that too. I think we'll also share that either on the chat and our social media changes. I think Martin is still changing something on his system before we begin. So let's give it a few more moments. I think another upcoming event we have is an extension of a cybersecurity career clinic we did during the Cybersecurity Awareness Month. So that talk is also on the YouTube channel. So the next thing we had planned to do after that was go into more in-depth areas, specific areas like analyzing of what we look for in CVs, probably share some of our CVs. We can have some people submit some CVs, then we can review them and advise on what could be something that can help them if, let's say, it was changed or modified. All right, I think Martin should be joining soon, then we can proceed. So Martin. Are you ready? I think still trying to sort out the screen sharing issue. So let's wait a few more moments while try to figure out what's the problem with Zoom and the screen sharing. So while we wait for Martin, I think he's rebooting his machine to come back. I think we can talk a bit about the whole idea behind the CTFs and the walkthroughs. So the Aspire program in its definition is to help young professionals in cybersecurity uh, gain the skills, prepare them for the industry, and just general career guidance and mentorship in the cybersecurity field. So one aspect of that was the skill aspect. And we realized that a lot of people don't have avenues to practice or somewhere to practice their skills. There are some resources online, but most of them are either spread across the web or don't take one from the beginner level. Also, a lot of the CTFs out there are focused on offensive security, so they ignore various areas. So we were trying to ensure that we have weekly CTFs that cover all the different areas. So we broke down the areas, and during each week, we went through a specific CTF. And hopefully this has been of help to people who were starting out and those who are also building up on their skill. As we moved along, we also started incorporating some harder challenges so that there was a progression of improvement as you went through the various weeks. And from the walkthroughs, then you have a perspective of how the creators intended the CTFs to be solved. So hopefully this is something we can make a regular occurrence even after we are done with this. So we will continue exploring new areas, trying not to repeat similar areas we've been through before, but to progressively tackle different areas. So with that, I think we have Martin back, and it looks as if he is able to share his screen now. So I'll hand over to him and he can start the walkthroughs. Martin? Yeah, I can hear you. You can begin.
I think I've been able to solve some technical issues.
Okay.
I
can
think
also see your screen.
Yeah. I think the first challenge was called sanity. The first thing I think you can download sanity, which is simple as can be obtained a fact from APK. Let me open my terminal. Let me zoom. You have a file called sanitycheck.apk. The first thing we need to do is to check the file format of the file, which you type file sanity apk. From now you can see sanity apk is a zip archive file at least version 0.0 to extract. For Android application, the first thing to extract you can use, there's a tool called APK2, which is called APK2, which is used for extracting or archiving some Android applications. For extraction, you can do APK2, stroke decode because I'm decoding application, and the name of the application is called sanity. After archiving, now you have a folder called sanity check. Now you can change the directory called sanity check, change to sanity check. From here, you can see you have some folders and some files. During the analysis, the most important file is called manifest file, which is used for storing permissions, the name of the application, some activities, and index. We can check through it. We can do a cut, Android manifest file. From this one, you can see the application name is called sanity here. The package name is called sanity. And you can see the number of activities in the application is called, there's one activity called main activity, which is our activity of interest. I think the next thing we need to do is now is to install the application to our emulator, which is ADB. Now I need to start the emulator. I come here and go to Android Studio. As you wait for Android Studio to open, there's another you can solve the challenges through use of strings. You can come to the application again and do strings stroke sanity .apk. From this one, these are the strings in the application. The first thing to notice you can grep if you know the file format of the flag. Example, you can do some grep. You're piping the application of the strings. Then you're greping the one Aspire. Aspire. Because you know the file format or the way the Aspire flag looks, you can grab it from the strings and you can get our flag, which is Aspire 2C4, which is the D5 sum of welcome. Let me open my Android Studio. We can now submit our flag today, which is our first flag, to check if it is correct. I think we got the right flag as we wait for the Android Studio to start. Let me start it manually. I think there's an issue starting Android Studio. I don't know why. Let me check. Let me open a new window. I think let's wait for the Android Studio to start. I can solve the second challenge. The name of the checkpoint was called login, which was supposed to get the correct username and password. You download the application, which is called simple login. From here, you can see you have another application called simple login. It's an application. We can check the file format. Simple login, which is the same an Android file format, which is APK. Therefore, for analyzing this one, I use a tool called Jandex, which is a tool used for analyzing Android application for static analysis, which you can launch. The application is called Jandex. There's a graphical version of it. For this one, you can select our application, which is called simple login. You come to downloads. Then you select your first application, which is called simple login. The first thing as you're analyzing an application is you look at the resources. From here, you can have, let me zoom in. Zoom. The resources section. The first thing to do is to analyze the manifest file. I think everyone can see my screen.
Yep.
I'm trying to zoom in here, but Zoom is not working. The other way I can do is to use, I can decompile the application, then load it to VS Code so that you can use. Therefore, I can do Jandex. Then the name of the application is called simple login.apk. As you can see now, the compilation has finished. We can open the folder, which into code login. From this one, I can now zoom out so that everyone can see. The first thing to analyze is called the resources session, which you start the manifest file. From this one, you can see the package name is called simple login. From here, you can see the other important thing is permissions. You can see you can debug our application, which is true. The other thing is, which is not supposed to be in a production, is called around backup, which is set true. The other thing is an activity. For this application, you have one activity, which is the main activity. And you can see the main activity is launched by the phone launcher because there is an intent filter. For this one, you can go to the sources and look for the main activity so that you can start our analysis from there. From here, you come to sources. You know the name of the application is com.aspire simple login. You come to com directory, which is here. You come to Aspire. Then you have three activities, which first it is build config, activity, and resources. But the activity you are interested in is the main activity, which is the file is called main activity.java. From this one, we can see you have three elements, which is a button, a login, and username. The first thing to analyze here is you have three methods which an application start can be either on create, on resume, or on delete. For the on create method is when you start an application, you create that method. For this one, you have like dream boxes, which is called end test, which is the username, password, And then you have a button, which is called login. For this one, this login is referenced by the button, this one. The goal of this challenge was to see how anti-content strings or credentials can be abused by an attacker. From this function plugged on create on main activity, we can see we have some base64 decoding method, which decodes some user and decodes some pass. After decoding these two values, we are comparing the values of decoded user with the username we entered in the application. And the other thing we are then we are comparing the password the user entered with an decoded pass, which is standard. If the conditions are true, we print a test contract credentials, flag is aspire user pass. If it does not meet the condition of if, we make a test which is wrong credentials, try again. For now, or I can use my device. Let me try to open it in the second. I don't know if it's not working. I think there's an issue with my Android Studio emulator. It is not starting, but I can do manually decode the values of decoder user and then decode password. For this one, because it is a base64 password, we can use a tool called base64 in Linux to decode the user and to decode the password. For this one, you can copy the value at user, which is why this one. You do a control copy. Then you come here, you do echo. You want to echo the password, the username. Then what you want to do is to, because you are doing some base64 decoding in the source code, we can pass this value to base64. Then you do decode. Therefore, you can get our value, which is the username, this one, which you're comparing to, decode user with the user, which is admin value. The other thing we can do is to decode the password, then decode pass to get the value. You copy the value here, which is control copy. You do echo. You pass the value here, stroke base64 stroke decode. From here, you can see now the username is admin and the password is password. Password at password. From this logic, because now you have the decoder pass, decode user and decode pass, you are comparing the username and the decode pass with the value entered by the user in the login dialog. If they are equal, we see that credentials flag is aspire user password. Therefore, for this one, you can enter a password here with the format, which is aspire. You can do aspire. For this one, aspire. The username is admin. And our password, you can copy this one, which is here, on the content password. This one. From this one, you can know now our flag is Aspire admin password. From here, you can test the password in the web application. We try to put it here. I think now you have solved the second challenge. Any question?
I think we can proceed.
Okay. I think we can go to the third challenge, which is count pass count. For this one, it was about the user login to the application on June 5th. What engine they use? In the node of the application, the name of the application is called pass count. We check the file format, which is the same for Android. Pass count. For now, what you can do is you can unzip the file and do some decompilation. We decompile from the .vk executable count to Java, which is human printable count. We can create a directory count, password, pass count. Then what you can do, you can use Jandex to decompile the application. Jandex, we specify our directory, which is pass count. And the name of the application is passcount.apk. From this one, you can see that the compilation has finished. We can open the folder with VS Code, which I do code, pass code. For analysis, the first thing to do is we start at the manifest file, which is the entry point of every application, Android application. From here, you can see, which is the same as the previous challenges. The name of the application is count, Aspire pass count. You can see the minimum build version, which is 30, which is the version of the Android Studio used for building the application. The other thing you can check is the permissions, which you can see Android alarm backup is true. The other permission is debuggable, which is true. From here, you can see you have only one activity, which is called main activity. From here, the first thing you can do is to go to the main activity so that you can understand the logic of the application. You can go to the sources and check the folder name of the application. Because you know the package name is Aspire pass count, you can go to directory here, you can go then to Aspire. Because you're checking the main activity, you can go to the main activity of source code and analyze it. Let me reduce the font. From this on, the first thing to look at is the method which I used in the application. The method used for launching an activity is called onCreate, the onCreate method. From this method, we can see our application has two buttons, which is for input and pass button. Therefore, when you click a button, you are passing some string to validate function. You have a function called validate, a class. For this one, we are passing our user input to validate. For this, you are passing a pass input. Then you're doing some calendar instance, which is a Java function. Then what you're doing, you're comparing our input to, if it is equal to integer to string. There's some math calculation here. You're doing some mathematics calculation, and then you're checking if it is true. If it is true, we connect the correct key. If it is not true, we do wrong key, try again. I think for this one, we need to understand the logic behind what are we comparing with the pass input. Because our pass input is from here, the main activity on create class, we are getting the string from a user, then you're comparing it to the value you're returning from the string. But what we are doing now, we are getting our instance, which is used for calculating the math calculation from the calendar. From this, what you can do is you can create a simple Java file to solve our calculation, which I can do this one. I take this function here, this line here, we copy, then we create a new file. We copy our file here. This one from here, we do a system enter. We are comparing the pass input, compare with the value from the math calculation. From this one, you can see I'm getting an integer. Then you're doing some math for. This is a math function. Then what you're doing, you're creating an instance. Then we're looking for, after this one, we compare it with our pass input here. For this one, we can do some solve with Java. I have a simplified code. Check to here, which is called solve. Aspire solve, this one. This is the implementation of this function here, which is you're getting an integer to string, then you're doing some form, which is a math calculation of getting some data from the current input. From this one, you can see you have to class over. I call it class over, which you're passing as an argument, which is a class of main class. You can see I'm declaring a calendar get instance for this one, which is here, the line here. For this one, you want to calculate only this value here, which you are coming in and calculating here, which is you want to print math form get instance get 3 instance 1 then remainder. For this one, you can compare the application and see the output. Which I will copy it here, which is copy the current directory. Our server look like this, which is cat.java, which is you're importing this function because you're using it with here calendar instance. Then you want to print the password for this math function here. You can do compilation, which is you can do Java green.java. From this one, you can see we can get our input is 13,632. But from the challenge description, we are told that the user begins application on June 5th. What key did they use? What you can do to solve this one to get the correct flag, we can set our date to be on 5th June this year. You can go to settings, and go to date and time. Then I can set the date to be on June 5th. This one. Then you can go back to our challenge. We can now learn again our solver, which is Java 3.java. You can see the person is different because it is getting the person from the date. We can now go back to our challenge, which is here. Now, because if it is equal, the key is correct. If it is not equal, the key is wrong. Now, because we have a correct key, we can go and input our key here to validate the key, which will be, our correct key should be 706 and 9. We copy this one. Then you can go to Aspire. Okay, it's our key there. We check. Which is, now you can see you have been able to solve our challenge 3. Any question?
It's okay, we can proceed. I think we'll have a pause at the end where we can have any pending question.
Okay. I think now you can go to challenge 4, which is pre-rendered databases leak secrets. The aim of the challenge was to try to teach people about why not to pre-run the databases. You can download the challenge. You can open our challenge there. You can check the challenge. The challenge is called, cannot see it, SQLite.db.apk. You can clear the screen, which is this one, SQLite. Create a font account, make then you can do of the challenge. This
Martin, I think your mic is currently muted. Yeah, it's okay now.
I think it was internet drop down.
Okay.
I think now you can open the application with VS Code, which you can do code, which is our target. We open the target directory, which is AspireCTF. We can do AspireCTF. I think when you are starting analysis, the first thing to do is to check the manifest file of one application, which is located in resources folder. We come and open manifest file. The manifest file we check for the application name, which is B2, which is written here. We come and the activity. You have only one activity, which is called the main activity. The first thing to do is to analyze the main activity. For this one, you go to sources. You go to com directory because of application name. You go to Aspire. Then you can see there's some files here. But the main activity is called our main activity is called main activity. You open it here, the source file of the main activity. For this one, you can see you're doing onCreate method. For the onCreate method, we are doing some called main activity .kt. This is because of Kotlin. The application was written in Kotlin language. We are doing some low query to the database, my database helper. There's a class called my database helper. Then you get the readable table entry. Then from there, we are selecting. We are doing a select from frag, which is our table. From this one, you can create a roadmap from there, which is application analysis. From here, you can see we are doing a select from frag. We copy this one, which will help us. Now you can know you are starting from our table, which is called frag table. Table which is frag. Then for this one, there's an activity called main activity coaching, which is this one. Now you can go to this one. From this one, you can see I'm doing some AspireCTF queries from a query from this query from string S. It is a string, which is our database from this one. In order to check for the databases, now we need to check for the resources to see if we have any assets. For this one, I come here to resources. I come to assets. From here, you can see we have two assets, which is our database here. It is called Aspire. From this one, you can copy this one. I'll change the working directory, assets. You can change to a font which is called AspireCTF. You can change to resources. Therefore, you can go to assets folder, which is on DB installed. You can go to assets. From this one, you can see databases. We change to databases. From this one, you can see you have one database called Aspire. You can check the file format of the database, which is called Aspire. From this one, you can see the file format it is a SQL3 database. For analyzing of on databases, you can use the two tools, a command line one cont, SQLite3 or SQLite browser, which is a graphic one. We can use the graphic one to analyze on DB, which is SQLite browser. Then you can open our file, which is cont aspire. Let me background the process. Let me can see my font.
Yeah, proceed.
From the database, you can see you have three tables. Which one is called aspire? The other one is called, and the other one is called persons. But from our analysis, we know we are doing a query on. You can come here back to aspire, our main activity. From here, you can see I'm doing a query, a row query on select from flag, which is our main table. Then you can open on DB again. From this on, you have this table called flag. It has three rows: flag 1, flag 2, flag 3, and flag 4. For this one, you can proceed to browse data. You can come here to flag. Then from here, you can see you have some values. It's flag 1, flag 2, flag 3, and flag 4. From this one, you can decode every value using the 64 because you know the format of the 64 due to the last two dash. From this one, you can copy this one. You come and copy this one. Copy. You come here to analysis. You come to flag 1, which is this one. You paste. You can go back to copy of flag 2. Copy. You come back here again, flag 2. You copy paste. Then you go to flag 3. You come back here again to flag 3. It's the value is this one. You copy. You copy, then go to flag 4. You copy the value here. Copy the value and put it here. From these flags, we know the values are base 64 and content values. Now the next step is to do some decoding. You can do some decoding on the 64 every value here. You can come and go back to a terminal. You copy this one. You can go here. You can come echo our flag, our value. Then do some decoding. You pass it to the 64 to then you do decoding. The flag is base 64. Let me check. Because this value being 20 is an invalid input, it is because what we can do is we can put flag 1 together, flag 2, flag 3, and form a base 64 full value, which can be, we copy this one, we put here the first value, flag 2, flag 3, which is this one. Then you come to flag 4. Then you come to this one. Then you can copy the value here and put it here. You can do now echo. You put the value here. Then you do some 5 to 64 stroke decode. Now you are told to get another int here, which is you copy this value, We come back to the analysis here. The flag is that the link given paste binding aspire password. Now the int here is to go to the table of password int was to go to the password table. We go back to our DB. From this one, you can go back to our data structures and look for the structure. You can see you have now a table of passwords, which you can see you have admin, Android, Linux, Aspire, Android One. But from our analysis, what we're interested in is the Aspire password. Now you can open passwords. You can go to browse data. You can go to passwords table. Then I can zoom in for everyone to see. From this one, you can see for every user you have different password. Like for me, it is 1, 2, 3, 4. For Linux, LP. For Aspire. Now, because you have an int, you're looking for the password of Aspire, you can copy this one, which you can do copy. Then you can come out, paste here, which is you paste the value here. Now, because you know the flag is that this one Aspire password, we can try now to put our password inside here. You can do HTTPS, stroke this one, the link paste bin, stroke. Now the password is for this one, Aspire user, which is this one. Let us visit the link now in browser. We come here and go to a new tab. We paste and go. Moving our connections.
You're missing the .com.
I need to change the date so that
the pastebin.com. You just have pastebin.
Yes, let me change my date first because it is complaining. I need to go back here. .com. Okay, thank you. Then we copy this one, we copy the link, you open back again. For this one, from here now you can see our flag which is called Aspire, pre-rounded, SQL DBs are never safe. You can try to input in AspireCTF to see if it is correct. You come here to flag 4. Send. Yeah, I think now it is okay. I think you can proceed to the challenge 5. I think for this one is give me a correct password and then give you back a shell. Static analysis is a good skill to have. You can download our application, save the file. The file name is called dropper. You can clear these ones. You can go back to a downloads directory. Now, because you have a file called dropper, you can create folder called analysis on dropper, drop. Then I need to copy the file dropper to the folder which I have created, drop. We change to the directory it is called drop. The first thing to do is to check the file format. File, dropper. From this one, the file format is at 2-bit executable. For this one, you cannot execute the binary in our system because it is x86. For assembly, they are most used in mobile applications, IoT devices. For analysis, for this one, you can do from the description here, you're told static analysis is a good skill to have. From here, you can do with your tool of choice, you can use either Ginja, IDA, or you can use Landary2 for analysis of ARM binaries. The first thing to do you can do is to strings to check if there's any important strings here. You can do strings. You can check all the strings and see there's a function called main. You can see a scoring system. You can see I'm doing something compare and some libraries here. But the most important thing is there's a name called welcome to AspireCTF bot. There's input admin pass bot. Then there's bin sh. From the description here, you can see give me a correct password, I will give you back a share. I think the share you're getting back here is bin sh. From this one, I'll be using Landary2 to analyze the binary. The first thing you can do is to turn the binary to /2, which is Landary2, the shortcut, and binary is called dropper. The first thing to do is you can do some auto analysis. You can do auto analysis, you can do the command AA. For this one, you can see done some analysis. See functions you have, you can do FR to list the functions in the binary. But because you know from this one you have one function which is called the main function. For C programming, the main is the entry point of the binary for analysis, which is the first function to be called by the binary. For the compilation of the assembly, in the binary, there's a command called PDF. Then you can select the function you want to deassemble, which is called the main function. You can select it with @main, which is this one. For any analysis of assembly, you need to have a goal, which is what do you want to do. For this one, from analysis is give me a correct person. The first thing all I need you can get is you can check any function that is doing some percent checking or some input. For this one, I can explain some bit of which will be applicable in other charges. The first 3 lines here, which are pushing at 7, is to the stack, having the previous are 7 registers. Then from this, the second line here, some allocation, you're allocating stack some 28 bytes. Then from here, you're doing some stack alignment. But here, the main thing you can do, and doing some welcome to AspireCTF bot, which is a string, which is an important one, which are reading from this value, from this memory address to a 3. Then you're displaying the value to a system through, you're moving A3 to A0, which you're copying the value A3 to A0. If we can continue a static analysis, which is you're putting another value and printing it, which is called input admin pass. The value input admin pass is stored at this location, which is 0x738. And then you're reading the value from the memory register to R3. Then you get the output to the terminal. Then from here, you can say you're moving some values, some ASCII. The first value you're moving is 0x61, which is we are copying the value 0x61 to memory address R3. Then the next instruction here, we are storing the value R3 to the memory address S2. From this one, you can come to our note and create a note here. Let me open. I come here and create a new note for analysis. I can come and create a new. For this one, you can see our first thing you're moving a value 0x61. Move is the same as copy. Is the same as copy. You can see you're moving the first value, which is R3. We are setting it to 0x61, which is A. Therefore, you can continue analysis, then come again. You are moving the second value 064 to R3. After moving, then you are storing the byte to the memory address variable, which is defined here, variable 19. We can check what is the variable 19 here. We can come back again here. Variable 19, because we are storing the value in the stack, we are storing the value at stack pointer plus the offset, which is 19. We can come back here. We put in our note. The second value is we are setting R3 to value 0x64, which is value D. We come to another value called 0xD, which copy the value 0xD, which is here to register R3. After copying the value to the memory address variable 1AH. Now you can come and set again. We are coming to R3, which is 0x6D, which is the value M, character M. Then the next instruction we are doing a move 0x31, which is the value 1 to R3. After moving the value, because one is one byte, we are storing it back to memory address variable 1H. You can put back here in our analysis. R3 now is set. R3 equals to 0x31, which is the value 1. Then you can come back here to the next instruction, which is we are moving the value 0x5, which is the underscore, to memory address R3. Then you are storing the byte back to the memory address variable 1C, which you can come back here and put. We are moving the value to R3, which the value is 05F2, which is underscore. Then you come to the next one, which you're moving. We are copying the value 0x41 to register R3. Then you are storing the byte to memory address at variable 1DH, which is in our stack. You can come and say now the value of R3 register is 0x41, which is capital A. Then you can come here to the other value, which is you're moving, copying the value 0x42 to R3. Then you're storing the byte R3 to memory address variable 1A, which is R3 equals to 0x42, which the value is B. From here, you can continue the analysis. We can see you're moving another value, 0x30 to R3. Now you know our value R3 is, R3 you're moving another value called R3 equals to 0x30, which you don't know the value here, but you can check. From here now you can see you're moving another value. Then after moving the value to R3, you are now storing the byte from register 3 to variable 1f. Therefore, you're moving another value, which is called 0x54, which now R3 equals to 0x54, which you come to check the value. Therefore, from there you can see, after moving the value here, we are moving the value to memory register variable 20, which is a want, here. Therefore, because it is a want, R3, we are combining all the values from, let me put like this one, R3 plus 0 plus 1, R3 plus 2. We're putting, because they're being stored in the stack, so that you can do the bytes. R3 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Now, because you're storing the byte less than 054, then even you're storing the value out of it to the memory and just variable 20. From here, you can check for this one in the terminal. After that, you're doing some scan. You're scanning some user input, which is a C function, which scans some user input. Therefore, you can come back to R2. We are doing some string compare. We are comparing two values, which is R2 and which is R1 and R0. What is the value of R2? The value of R2 is this our string stored here. The value of R0 is the user input. After that, you compare the user input. The input, after comparing the user input, the return and the return output is stored in the register 0. Then the value we are returning here, if it is 0, the values are equal. If it is not 0, the values which are being compared are 1 and are 0 are not equal. Therefore, we come and compare R3 and R0. For compare function, what we do is we do a subtraction. R3 minus 0. If they are equal, we take branch correction if equal to this function, to the memory address here, which is 0x6fa. For this one, if they are equal, we are executing our share. If it is not equal, we are coming here and displaying some name, which is bot update check field. We print this one. After printing the bot update check field, we branch to this memory address, which is 0x708. You come here and put 3 to 0, which I think it's the return address. And for this one here, down here, we are checking some canary, if there's any stack smashing, something like that. Therefore, for password, you can come now back to the terminal and check the values and compare the values which are. I can do a quit. Then I can come here and do. I want to check the value which is 0x30. You can do man ASCII. For the value, you can come and check here, which is hexadecimal 0x30. For this one, you can now the value 30, which is this one, which is 0. Now you know the value that is 0. X30, the value is 0. For 0x54, you can come and check this one, 0x54. Next decimal, you come here, back again. 0x54, which is here, ASCII table, which is 54, which is capital T. You can come here and put capital T. Now. For this one, you can put the string together, which will be ADM1 underscore A B 0 T. I think this is our password. From the logic here, which is come back here. From this one, R2, dropper. I come and do some analysis. Main function. From here, you can see this value is stored at this memory address, which are coming to and all of them are to S1, R3. We are adding all of the values which are stored in R3 and storing them and storing all the values to R3 register. From this one, you can see S1 is our string, this one, which is our S1. For S2, the string S2 is our user input and then you are comparing the two values. We put here 0 as 0 to 0, then copy the value because they are equal, we copy to R3. If we compare 0, assuming they are equal, it will branch to this function here, which will execute our share. We can test our password if it is equal, it is okay. You can come and copy the password. This one, we copy. Then we check to our challenge. The flag format is Aspire password. And we know our password is admin bot. I can come here and do Aspire. I can come and do admin bot. You can check our password. I think the flag is correct. Everyone is okay?
Yeah, let's continue.
Okay. The next challenge is called challenge 6 is called key. Help me recover the flag. I lost the binary. Provide the answer in decimal. We can save the challenge here. I can come back here. Let's go back. Go back. From here, you can see you have done an application, which is called key, which is challenge 6. Because it is a zip, you can unzip it, which is unzip key. Let me create a directory, yes, key. Then I can copy arm key to arm key from this one. We can change to arm key so that we can do analysis from there. From here, you can do unzip file for unzip, because it's a zip file. From this one, you can see you have three files, which is DB, key, and randare.key. For this one, the first thing you're provided is source code and assembly code. The first thing I can do is we check the source code, which is a C program, which is vim key.c. For this one, the first analysis is to look at the main function, which is the first function to be called by C program or any component program. The first thing you can see, you have a variable called key, which is setting to 0. Then you can see you are printing mobile ransom ARM chips. Then the next instruction is we are scanning some user input, which is stored in the key variable. Then you're doing some check here for the function. You can see you have two functions, which is key1 and key2. Then you're checking if the value beyond the value of key1 and key2 is equal to key. If they're equal, we do flag is address key1 plus key2. If they're not equal, we come and print ARM assembly manuals as a source of inspiration. Then the program exists. The goal of this challenge was to understand the working of program counter, which is the next instruction being executed by the ARM assembly. And the key2, the goal was to understand about the return register. When a function or a stack frame finishes executing, where it returns to the address to return to. For this one, we can do, because it is static analysis, I can open this from the VS Code so that you can do analysis from there. Code. From this one, the files are the same. The first structure is the same as the one in the terminal. For this one, you can do this is the main function, a starting point. You can do this is a starting point. Let me do some starting point for analysis. What you're doing here, you're checking the value of key1, which is this one, plus key2, which is the function is this one, are equal to our input. You're printing printf. If they're correct, you're printing the flag is address of key1 plus key2. The first thing of key1 is to understand what is a program counter. Understand program counter, which is program counter for this one. The other instruction was about understanding about linked register. For this one is inline assembly. In C, you can put some assembly source code in your high-level source code like this one and execute it directly in the chip. For this one was about linked register. For this one is the return address after functions finishes a function stack frame finishes execution. For this one, program counter is the next instruction to be executed. For this one is the same as for x86 assembly, is the same as EAP. Next instruction pointer to be executed, or for x86 64 machine is for RIP register. The first thing we can go and check the assembly source code. We can go with the GDB. For this one, you can go from function there. For this one, the thing you need to understand is mapping the source code to assembly. From this one, you can see you're doing some function prologue. You're setting up our stack. You're saving register 4, R7, and link register. From there, you're printing some values here, but I can use for random because this one is not, because this one is static. You can use for random because of some analysis. You can come here and switch for this one. For this one, for the main function, you're doing some saving the same, saving R4, R7, and link register. You're allocating some value to the memory. Then you're setting our start frame to be at the same point as frame pointer, which the frame pointer is R7. Then for this one, you can see there's a printf. Let me so that you can fit here. For this one, you can see there's a printf here, which is mobile runs on ARM chips. For this one, we can come and map with our key here, which you can see executing here. Printf mobile runs on ARM chips. Then the next thing you can come, we are doing some scanf. Scanf is you're getting some user input, which is you can go back to our source code. You can check this out. You're doing a scanf to, which is an integer, the file format, the format here, which is an integer. Then you're storing the value at memory referenced by key. We come back here again. For this one, R3, which is our key, which is referenced here. The first thing you're doing here, you're branching to key1. From branch, it's like you're doing some branches, like you're moving from this function, you're calling this one branch to key1. You're controlling the control flow of program. Now you're going to key1. Now you need to check what is the function of key1. I'm branching to this one. You come here down here. For this one, it is key1. For key1, from our source code, from key1, we are doing some assembly move, which is move program counter to register 3. From here, you can come and see this is our stack frame, which is you're saving the R7, which is the memory address to return to after finishing, which is our stack frame. This is our stack frame R7. Then you're doing some stack adjustment. You are setting our stack pointer, the top of the stack, to be at the same level as frame pointer. Then you can see from here, you are doing some move program counter to R3, register 3, which is the same as move program counter to R3. For program counter, now to know the address of program counter, we can come here and say program counter, which is PC, which is the register PC. The register is 4 bytes ahead of the current executing instruction. Because now you're moving the value of program counter to PC to the memory address here. For our case, because program counter, the value here, it is 4 bytes ahead of the current executing instruction. Now, in order to know a program counter, you can come and take this one, the memory address here, and put here. This is our current executing. For program counter, it is usually the current plus 4 bytes, and which will be now our program counter will be the memory address here plus 4, which is this one. We get the value is 0628, which is this is a program counter value now. The program counter now here, this is the goal of the function 1, which is here. The value of the memory address at program counter, which is 00628. From here, you can come back again to, from here, this one is a function epilogue. We are cleaning up the stack and restoring the previous value. This one, you're doing a branch linked register, which now you're going back to the previous, to the main function. You can now go back to our main function here, which is here. The program will return to. The program will return here. The execution control, the execution will come back here. Now, the next instruction is we are going back to function key 2, which is you are doing a branch. And branch is like your control, the control flow is changing from the main function to key 2. From now, you can come back here to our source code, which is key 2. From key 2, the goal was to understand about linked register. And what you know, the linked register is the memory address we return after finishing execution of key 2. From where we return, after executing key 2, after execution of key 2, we return back to main function, which is our main function, which is the linked register. The address at the main function. We can go back to our assembly code, which is around 2, and understand the function 2. For key 2, you can see we are doing the same function prologue here. We're saving at 7 register. We are setting a stack pointer and adjusting it to 0. Then you can see our function. We are saving our value linked register, the value you're returning to. Then after doing some function epilogue, we are returning back to where we are from the main function. From here, you can come back here. After execution, our program will come back to this one. After executing this one branch function, our program will come back to 0680, which is here. I can come and copy this one, which is our address, linked register, the main function. Copy the memory address. You can come here. The linked register, which is linked register, which is the value is this one. This is executing linked register is where we return link. Register is where we return after execution of our function. I can come back here to understand our logic. If key 1 and key 2 equals to key, we print flag is address of key 1 and key 2. Else is assembly manual source of. You are doing some addition. You can see you are doing some addition of key 1 plus key 2. The memory addresses of key 1 and key 2. And because you know the value of key 1 and key 2, you can come and copy the value of key 1, this one, which is here, plus this one, the value of linked register, which is here. I can do some addition here, which for this one, the value of these ones, we can go foundation, we can do like a foundation. We can copy our values here because you know them, foundations. I can paste the values, which is the value of function counter, which is this one. The value of function counter, which is 628, this one. Then you're adding the value to 680, which is value of T2, which is the memory address of link register. For this one, you can see I'm getting our value, the key, which is 3240. Now, because help me cover the key, I lost the binary. Now, because you have the decimal, which is 3240, we can now enter which is a fractal because you have the correct key now. You can come and enter a key here, Aspire 3240. Let me check if it is correct. Perfect. Are you okay?
Yeah, let's go on.
Challenge 7 was about understanding about real-time Firebase rules. For this one, I'm given an int about, hi JSON, our real-time Firebase is taking some data. Can you help us figure out which data it is taking? You can download the application, download our application. Let me exit here. Exit. We come back to downloads. Now you can see we have a file called Firebase, which is this one. You can create a directory called Firebase. You can now change to Firebase. You can now copy our file, which is firebase.apk to Firebase directory. You can change to Firebase directory. For this one, because this one is an Android application and the file format is the same as for the previous one. For this one, for analysis, you can use Gendex, which is I can come here and do. For the compilation, I can create a folder, which will create our output, make directory output. It's an output. You can come and do some decompilation. Gendex. We decompile application to the target folder, which is output. The file name is called Firebase. And wait for a couple of seconds before it finishes the compilation. Therefore, you can open this folder without VS Code. I can do code output. I think for this one, you can understand the first thing to do analysis is to check the manifest side, which is this one. You can see you have more information compared to the last ones. The first thing to check is the Android application name, which is defined here, which is package, AspireConnect Firebase. Therefore, you can see you have some permission, which is accessing some internet. There's network state, which is checking the network. Then there's internet. Therefore, you can come and see our activities here. From the manifest file, you can see you have only one activity, which is called main activity, which is called AspireConnect Firebase.main activity, which is our activity. Then from others, you can see you have services like Google components Firebase. Because Firebase is owned by Google, you can see some services by Google for Firebase. Then the provider, which is Firebase init, for creating an instance of the application. Therefore, for analysis, you can go to the main activity and start from there. You can come to com, because you know package name com, then the directory here, Aspire Connect Firebase, which is this one. Then because you have an activity called main activity, you come to this one. For this one, we start analysis here. Let me create a new file for analysis. For this one, you can see you're creating a Firebase database. Protected Firebase count, this one, which is the reference to the database. You can now come and see and copy this one and do some database reference here. Just called the reference, you're referencing to this one. The referencing of T. Let me copy it and put it here. This one. Then there's protected test view flags. Then you come to Firebase reference root node. Then there's a button called update. I think for now, because my studio is not showing up, it is not starting, I may not be able to show the application, but I'll explain out of it so that the person can do. For you have an activity called main activity. This is from getting the instance of the database. From this one, you can see I'm getting a Firebase get instance. Then you're referencing this instance, which is instance. Then from this one, you're getting some reference to Frax, which is our node, which you can come here to. From our database, we are referencing some node called Frax. For this one, you can come here to the first method to be called, which is on create when you start an application. For this one, when you click, you have a button called update. When you click update, because it is listening, it is like you're fetching some information from the database. From this one, you come to on click. When you click the button update, you can go to the database, which is referenced here, guest instance, which is a database F274DB. Then what you're getting is Frax node. For this one, you're getting the node of Frax, which is this one here. Then you display them to the screen. If you are not able to get some data from the database, from the log cut, you get CTF field to run database. If it is successful, you can get some tests on the screen updating Firebase database. Coming back to instruction here, every time that Firebase is taking some data, the first thing to do is to check the URL. Because you don't know the URL of the Firebase, we can go and check. It is most of the strings are URLs are stored in the strings. You can come back here to our resources. You come to this directory called list, which is resources. For this one, you can go to, there's a directory called values, which stores values, strings, everything reference in the application. You can come to this one. For this one, you're looking for strings, which are in the application. For this one, you can go to, because we are looking for a string Firebase, we can do something like research for Firebase. Let me search for something like Firebase. Like this one, quantifier, can search for Firebase. There's one instance. Then there's another one. From this one, we can do some testing. This is the link over Firebase where the name is. There are Firebase databases. You can copy the link here, copy. The link to our Firebase database, which is this one here. You can check it and move these ones, and move these ones, and move the other one. Okay, that one is okay. This is our URL to our Firebase instance. For this one, what I explained about the rules, which is I come to have an instance running here online, which is this is my Firebase, so that I can explain the rules. From my screen here, you can see this is my Firebase, which I'm hosting in my account. For this one, I have two instances, which have two nodes, the frag node and the secret. For this one, because it was about teaching about the rules, for this one, if you check the rules, for this one, the rules of the Firebase, everyone can do a read and write, but write is false. For this one, because you are not getting any node, you are getting the node of the data. Application will fetch both the frag and the secret node. For this one, you can do a test using cache to see the information you get from our database. For this one, I copy the URL. I'll come back here to VS Code. Let me check the VS Code protected. This one, I copy the URL. Copy. I want to see the data I'm getting from the application. If you run the application, you use cache to get the data from the URL. From this one trick for checking if the database is vulnerable or not vulnerable, you come and add .json and .json at the end of the URL to check if the database is vulnerable or not. Check if the database is vulnerable or not. For this one, what you can do, you can add .json. From this one, you can come .json to check. Then you can copy our URL again. From this one, copy. You come back to our terminal. You can come here and back here to the end .json so that you can get the data. From this one, you can see I'm getting some data, but in our application, you are referencing only the frag node. Let me copy this one. Copy. Then you can come back here again to and copy paste here. You can copy enter. From this one, you can see you're fetching the data of both flag nodes and secret node. But because this one was not, you can back to application here and check, confirm something. You can come back to sources, com, Aspire, main activity. From application, you can see you're getting only the flags. But now, because the Firebase is not protected, you can see you can get the adjacent nodes of the Firebase, which is secret. For mitigation of this one, you can come and change some rules so that you can protect your applications from other applications getting the data, which is to be secret. In order to get some data only for the ones you have defined in your application, you can come here and add some rule, which you can come and add some rule only to reference the Flags application. Come here, Flags. Because this is on JSON. Okay. Then because you have updated our rule, you can come here back again and do publish. Saving for this line. Okay, line 3. Publish. For this one, you have updated our file rules. For now, you will not be able to access the secret node. You can come back to run and confirm our hypothesis. We can do some color again to test. Permission denied. Yes, permission denied because now we cannot change. If I can come to, because now I'm not able to, the Firebase is secure. We are getting an error of we cannot change because permission is denied. Yeah, I think that's how you secure your Firebase. You only put the node which you are getting the data from. Yeah. I think from the analysis for this one, you can get, because you're editing some flag, you can know our flag is Aspire. Aspire Firebase is very secure.json. You can copy our flag here. Up to here, copy up to here. Copy. Up of flag 7 and do a paste.json. Then I put in bracket and do a send. I think now I'm being able to solve flag 7. For this one is the last challenge, which was an ARM assembly. Prove in Goto what it takes, give me a correct value, and then give you what you want. For this one, was about testing about control flow in ARM assembly. You can download the application, which is ReadPass. You can go back to our terminal. Can come here back. It is control pass. I can make a directory control. Now I can copy the file ReadPass to read. Now you can change to read. The first thing to do is to check the file format. File, ReadPass. For this one, you can see it is an ARM binary, which is ERF32-bit ARM version. This is the version NBA version 5, which is, I think, ARM 5, ARM 7. Therefore, you can see the binary is not stripped. you can see the interpreter. For this one, because you have an int here of user and studio and then disassembler. For this one, you can use because it is a ARM binary, you can use random because it supports ARM32 format architecture. I can come here and do random2 read pass. The first thing to do is to do some analysis. For this one, you can check the number of functions you are calling, which is I come to EFR. For this one, you can see you have a lot of functions because you have not done some relocations of the binary. But to start our analysis, the first function is called main, which is here. You can go to main function, which you can do printf at main. For this one, you can start from here. From our previous challenges, we can see we are setting up some stack. From this one, you can see a stack prologue, epic prologue, which are setting up the stack. We are saving frame pointer linked register. We are setting up the stack pointer to point to the frame pointer. We are allocating some values to the stack. From here, you can come and check. For this one, you can go line by line. Then I can provide data. I'm going right up on it. For this one, the first thing to do, we are storing a value. We are storing R2 to memory address reference by variable v4. You can come here and check variable v4 is frame pointer offset 0x08. Then you are storing second value, which is in R0 to variable h, which is argument c. For this one, you can see argument c is the name of our program, which is stored to variable h. The other thing you can see, you're storing a value R1 to string, which I think is argument variable 1, which is our input. Then what you're doing, you're rounding the number of arguments in variable h to, for round instruction, you do a round from memory address to a register. What you're doing now is you're rounding two values. You're rounding the value from memory address variable 8h, which is this one, which is our argument c. For this one, you can open a new file so that you can do analysis as you put some notes. You can come here, let me close this one. You can create a new file. Let me close this one, Control B. The first thing you are doing here, checking is number of arguments. You are checking the number of arguments, which is axis. And you know the compare, you're comparing, you're doing a compare R0 with 2, which we know R0 is number of argument C. For this one, you're coming and comparing. This is the condition after you compare the two values. Branch on greater or equal to, if the value of R0 is equal to 2 or greater than 2, we branch to this one, our control flow. You can see from the arrow this one, from the blue arrow, we come to this one. We come to this function, which we are storing now our string to R0. What is our string? Our string now is argument variable, which you can come and here put some notes. Our string is our argument variable. Okay. Therefore, the first thing you're comparing to 2, then you come to which you're storing it to R0. You want to run the value as string to R0. Therefore, R0 will be to the value stored at memory address referenced by string, which is our argument variable. From there, you're doing some array. For this one, you're converting our value to string. For this one, you can check the manual, what is array. I can change it to the terminal and command to man array function. We are converting a string to the integer. Because we are scanning 2 arguments, now the argument, which is our string, we are converting it to integer. We are converting the value here, this argument variable, and storing it to R0. Therefore, R0, we come here back again. This is our R0, which we are storing to memory address at variable 14. We command to, we store R0. Now our memory address at variable 14 H is the value at R0, the value at memory address R0. Then come and run the value at R0 back again to the memory address. We come back here again to, we can copy this one. We can command to R0 equals to, we are storing from there to the memory address there. Then now we are storing value from variable 10, which is referenced here to R0 to variable 10. Then because we know we are now storing the memory address variable 10, which is this one, can come and put some notes here. Variable 10 H now points to R0. Then what we do now, we run the value back to memory address R0. We can come back here and do R0 equals to variable 10H. Can I get 1 second? A break of 1 second?
Yep.
Okay. I think I'm back. Let's check.
All right, go on.
I think from where we left is that memory address 0, 980, which are loading the value at the memory address variable 10 to R0, which is here. After running the value, we are comparing the value at R0 if it is 0. If we can do compare R0 with 0. This is the same if R0 is equal to 0. Then you can come here. If the value you are comparing R0 is branch if higher, you're comparing the value of R0 with 0, and you're comparing if the value is higher than 0. Therefore, you can put some notes here. If the value of R0 is greater than 0. If the value is greater than 0, you are doing some branch, which you are going to this memory address 98. If it is higher, you go to this memory address, this one. If higher, if I go to this memory address 0x. The other thing is, if the value is less than 0, you are printing some value less or equal to 0 is not allowed. Therefore, from analysis, the thing we want to know is we need to come to this memory address or control flow. If we can come back again, you can see we are running our value of 14 back to memory address R0. You can come back here because you know the value at R14 is our input here. We are coming back here again and joining it back to R0, which is R0 is the value we are storing at variable 14H. The memory address at variable 14H. For this one, now you are doing some store from the memory address here to variable AH. But the instruction of store, now you're not holding the all 32 bit because I'm a 32 bit. There's store, which is 32 bit in size. Then there's store R1. This one here, you're storing R1 to memory address. The memory address. For this one, when you store R1, we store it into that 2-bit address. Then we zero out the higher 16-bit. Therefore, you know you are storing our 0 you are storing to EH, which now be variable EH memory address reference there. Storing R1 of If we can come to the next instruction, which now you are loading back the values on the memory address back to R0, but now you are comparing it R0, which is R1. Now I want to launch R0 again from the memory address variable EH, but now you are loading R1. From there, you can come now. We are comparing the value at R0 to 0. Therefore, the value here, you are compare R0 with 0. If we can come to instruction here. For this one, you are doing some branch if equal. Therefore, you do some you're branching to this memory address. Branch. I'm branching to this memory address if R0 is 0. For this one, if it is not equal, let's take an example if the value you are putting is not equal to 0. We are coming and printing some value here, value defined. Which value are we printing? We are printing a value on 0x17. You can come here and put some notes. If the above condition is not met, if the above condition is not met, you can do, you are printing a value, you print some value, then you do an exit. What is the value? What is the value? What is the value? Our value is here, it is 0x17, which is in decimal place. You can come and check the decimal place of this one, which I can come and here check the value in decimal. That's 2. I can come and check. For this one, you're comparing a value code 6102. You can copy this one and come and put here decimal, which is that one, 6102. Then you go back to assembly, which is the terminal. But now, because you're interested in this, we can come back here again and do some. You're loading the value at the memory address here, variable E to R0. But now you're loading an upfront. If you can come, because now you know this one is not needed, you can come to this one, control. You're loading the value to R0. Now you can know R0 equals to, you're loading another upfront because of launch instruction. Launch instruction, it is launch of, it is loading upfront from that to memory to R0. From to R0. Therefore, because you know R0 equals to variable EH, which is here, we run the upfront here. Upfront. Therefore, for those one, you compare the value R0 to 0. Therefore, compare 0 to 0. Therefore, you check the condition of comparing. For this one, BNE, the function, the instruction is called branch not equal. If the value of R0 is not equal to 0, you come and you go to this memory address reference here, 0x810, which is this one. Which is down here, which is this one. You come to an exit. Therefore, if R0 is not equal to 0, we do we do an exit. Therefore, if let's take an example, the value of our 0 is to 0, we come here, because of value of 0, you load our value here to the memory address here, the value reference the memory address here. Declaring this because there's no relocation of the disassembly design. Then what we do, we are passing the value at 0. For this one, we are passing the value to this function called decrypt. For this one, you can come and do. For this one, you can high level, you can map our assembly code, which is to be, we are passing our 0 to decrypt function. Decrypt, you can constant decrypt, which are passing at 0. Passing at 0. I think for this binary, the decrypt function was the one was used to enter the flag. When you control the flag and come up to here, you'll get a flag. For this one, I think you can now check our logic so that you can get the value of our 0. For this one, you can start from the beginning here. From analysis. From static analysis here, you can come. The first thing you're doing is you're running a value to argument variable, which is at 0. The second thing you're comparing if the value is 0. Therefore, for analysis, the value should be greater than 0. If it is greater than 0, we come to this memory address, which is the control flow up to here, which we are storing our value to the memory address, which is referenced here. Then you can come and say, store our input here. After storing our input, we can see we are storing upfront of this one, our input. Let's take an example of our input. Let's take example of our input. To be, let's take 0x 2000, which is this one. I can convert this one to decimal, which is, I can come here and do convert the value to decimal, 0x 2000, which is the value of this one, 8192. You can come here 8192, this one. For this one, you are doing upfront, you are reading the value from a 0 to this one upfront. For this one, you can put some notes here. When you're passing some values to the memory or in the assembly, the values are not passed as integers, but they are passed as hexadecimals. For example, for this one value, if you enter this value, in the memory it will be seen as 0x 2000, which is base 16. For this one is 0x 2000, which is base 16. For this one, it is base 8192. For this one, if you don't an upfront memory address variable AH, we can come here, and because this one is the value, which is our want is 0x 2000. If we run the upfront, the upfront of this one will be, because we're running the least significant values, this one, we want two values, which will be 0, 0. Therefore, for this one, now because the value here, we can come and say the value at VEH, the memory address variable VH is 0, 0 for this one. Then you can come here again and say we are loading now the value at the memory address at variable E back to register 0, which is upfront. Therefore, you can now come and say our want now is 0, 0. Let me separate this one. For upfront, now you don't the least significant, this one, therefore of this one of want, which will be upfront equals to 0. We are loading the value 0 to the register at 0. Then you're doing some comparing. For this one, because you know at 0 now, which is there at 0 equals to 0, you come and do some comparison, which is at 0, we compare, which is 0, which will come, which is equal. Branch, if at 0 is 0. Therefore, you can say our condition branch is true, but branch is true. Therefore, if the condition above is not met, we print some value, which is this one. The value this one was used as, this one was an int. This one was an int. Print some values. Then you can come back again. But if it is equal, we come and load the value from memory to at 0. Which is our values. Example, let's take our memories. Our want now is 0. When we load our fund and our value is 0, because others are 0, we load our value the same as 0. Our fund will be, for this one, our fund will be 0. For this one, the fund will be 0. Because when you load our fund, we are 0, the other memory registers, you're setting them to 0. Therefore, our fund will be 0. Therefore, you're coming and comparing again. We do a comparison. Now you know our 0 equals to 0. Because the condition, now you're comparing our 0 to 0. This is like doing our 0 minus 0. You are comparing it to 0. Because the condition is true, therefore condition is true. If the above condition is not true, what you do an exit, the program exit. But if it is true, we pass our value, which is 0, to the decryptive function. And because our 0 is true, we pass our value to the function. Okay. If you have passed all the conditions above, you've been granted with the flag. Because if you reach here the decrypted function, which our flag is encrypted, and run the program in an emulator, you get a flag. I think for the demo I cannot show this one because My emulator is not working currently. Yeah. But I can show the value, you can put the value, I walk through to explain that one. For this one, you can explain here. That is it. I think I can explain here what I was explaining the source code. For this one, you are doing some load values. The value is standard, start pointer. This is a dot set. Then the second thing is you're loading the value to register at 0, which is you're loading the value from the memory address for this one, value 14 to at 0. Therefore, at 0 now is the value in the memory address specified. The other thing is you're storing at 0 back to the memory address reference by the variable A. The instruction stores the reference to the memory address pointed by variable H, which are 16 bits in total. Therefore, you can take an example, take a value to be 0x2000. Therefore, 0 be rounded with 0x2000. Therefore, you can see the values here because it's a integer is 1 byte. Therefore, it is that 2 1, which is this one, that 2. Therefore, you're reading upfront, you're reading the value 0 0 to the memory address variable E. Then you put that one to 0. Therefore, you do again a round instruction, rounding upfront from a memory address to a register. We round back our 0, which is this one, to a 0 back again. Therefore, you can come back to. For this one, you can see our percent example. This one, because you're comparing, the percent can also be 0x1000. Therefore, you can do run in emulator in order to decrypt our flag. To install the binary true, you can just push this one. After you enter the correct percent, you can get your flag. I think that's all.
All right. Thank you, Martin. I think it was a very detailed walkthrough, and a good thing we have it recorded for someone who wants to go and recap and review some sections slowly for a better understanding. I hope everyone learned a thing or two, and you can begin or further your journey in mobile security, both the development, the reversing, and the security aspects. So again, thank you, Martin.
Thank you.
And this being our last walkthrough, this is the official conclusion of the CTFs that we did this year. Hopefully we'll have some fresh ones in the near future. So watch out for those updates. We'll communicate that as soon as we have the details. And hopefully we can use the lessons you've learned throughout the walkthroughs. As we had said before, we are also going to be sharing written walkthroughs so that people who prefer the actual written ones rather than the video ones can also have that as a reference. So thank you, everyone, and enjoy your day or your evening, and see you next time.